carbohydrates. Here's the carbohydrates quiz. I'm again going to try to help you guys without totally telling you the answer. So let's figure out which of some of these options are not correct. Disaccharide that contains fructose. So disaccharide is going to have two sugars in it. And glucose, let's see, that's a monosaccharide. So that can't be that one. And there's two other ones in here that just contain glucose. Let's see, dextrose is just another word for glucose. And maltose is a disaccharide, but both of those two sugars are glucose. So there's a bit of a story in your course materials about one specific disaccharide that gets broken into fructose and glucose, and the bacteria on your teeth use the glucose and polymerize it into dextran to kind of make a home for themselves, and then they use the fructose to as their food. They eat that, they metabolize it. So this special sugar that we're looking at for this question is a disaccharide that contains fructose and glucose. Let's see. An ene molecule would have a carbon-carbon double bond, and then no other big functional groups that would cause us to name it differently than ene. So probably not any oxygen in here. And carbohydrate, what is a carbohydrate? But something that has a formula of some number of carbons, twice the number of hydrogens, and then the same number of oxygens as carbons. Okay. You guys can figure that out from the slides. This part, hex or pent, tells you the number of carbons. So how many carbons does fructose have? You guys can count them up. It's not that hard. And then aldo means that it would be a sugar with an aldehyde functional group, and keto means it would be a ketone functional group. Thing about comparing fructose and glucose is that glucose has an aldehyde group, but fructose does not. The aldehyde group of the glucose can get oxidized, so it is a reducing sugar, but fructose is a little bit different. This is just something you guys can look up. Okay, this might be a little tricky. But, okay, what does it mean by chiral carbon? This is a carbon that's bonded to 4 different groups. Now, keep in mind, carbon makes a total of 4 different bonds. So every one of the 4 things that the carbon is bonded to has to be different. For example, if you see a CH2, blah, 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 that carbon is bonded to 2 hydrogens, which is essentially 2 of the same thing. A hydrogen here, a hydrogen there. Those are essentially equal. We consider those to be equal things that are bonded to the carbon. So if any carbon with 2 hydrogens is not a chiral carbon, because if it has 2 hydrogens, it could only be bonded to 3 different groups. So if you look at a representation of glucose, you can kind of look, count how many carbons have 4 different groups attached to them. An open chain, so that tells us don't look at the ring form of glucose, the you know the representation of the glucose molecule you look at should not be cyclical. It shouldn't be a circle. Um, but yeah, it just so happens that usually in our bodies it is not the open chain form. And cellulose is the glucose polymer that we can't digest. It's in plant cell walls, and it's another hint is that I refer to this type of glucose polymer as the stairway to heaven polymer. It kind of looks like a stairway going up, so you can figure out whether it's alpha or beta from the slide. This one's pretty. This is a pretty commonly known condition. The name pretty much makes sense. It's kind of what you might expect the name to be. Notice that pretty much all the carbohydrates that we talk about that are in our bodies are the D form. So we don't usually talk about L blah 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 sugar in living things. And remember, D stands for dextro, which means right. L stands for levo, which means left. This you can look up if you don't remember. I think I already mentioned this in this video. Yeah, this would be in a glucose. Let me tell you that in a glucose chain, with this type of hydroxide configuration, I would call it the bumpy road type of glucose chain. So if these glucoses were to polymerize and make a chain, it would be a bumpy road chain, kind of out there, kind of hint. Yeah, this is another thing you can look up. Mono means one, di means two, halo means salt, oligo means a few, poly means many. That's something you can look up. I already mentioned this in this video. You can look that up. Glucose and galactose combine to form this disaccharide. Sucrose is fructose and glucose, but no galactose. And then this doesn't make any sense because glucose is just glucose. It's just a monosaccharide. There's no galactose there. I think we already saw that malt